right, moving on to 1.4, collecting sample data. Remember we said it's very important that data is collected in an efficient way. If it's collected in the wrong way, then it's useless. If sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. Not a lot to this section, just a couple of definitions and things that you make sure you want to look out for when looking at data, maybe the types of studies, things like that. And in an observational study, we observe and measure specific characteristics, but we don't attempt to modify the subjects being studied. So you can imagine someone studying animals or even people, I guess as long as they had the people's permission, would be some type of observational study. Now if it's an experiment, in an experiment we apply some treatment and then proceed to observe its effects on the subjects. Alright, so observational study, we're not going to do anything, just watch. In an experiment, we'd apply some treatment and then watch. Alright, a simple random sample. A simple random sample of n subjects is selected in such a way that every possible sample of the same size n has the same chance of being chosen. So you want to make sure that any sample that was chosen has the same chance of being chosen. So like if I wanted to do a simple random sample of 2 people in here, I would want to make sure that I selected those 2 people maybe out of a hat or some random way, where if I was to make another selection of 2 people, I still have the same chance of getting those 2 people again. So the chance of getting you and me needs to be the same as the chance of getting me and you needs to be the same as the chance of getting 2 other people in the class. So every selection has the same chance of being chosen. Your book goes on to say, throughout we will use various statistical procedures, and we often have a requirement that we have collected a simple random sample.
What did you say about the random sample?
Every choice, well, here it is right here. Alright, so it's selected in a way that every possible sample of the same size, and it says the same size n, so it doesn't matter what the size is, every sample that you choose has the same chance of being chosen. So again, if me and you are chosen, or if 2 other people are chosen, that it needs to be the same chance of everyone being chosen. That's a simple random sample. Not of each person. I guess it would be if the group size was n, or n equaled 1. But sample sizes usually are groups of items, groups of people, things like that. Alright, there's a lot of different types of sampling. Systematic sampling says we select some starting point and then select every kth element in the population. So maybe I had a set of data and it was everyone's weight, and I wanted to choose, say, starting with the third person, the third lightest person, I wanted to choose every third person in that list. So you start at some point, and then you have some type of order or some type of I guess it would be some type of method of choosing every third, every second, every fifth person, something like that. Convenience sampling. We simply use results that are very easy to get. Convenience. Easy. So that's pretty easy to remember. That's one type of sampling. In stratified sampling, we divide the population into at least 2 different subgroups or strata, so that subjects within the same subgroup share the same characteristics, such as age bracket. Then we draw a sample from each subgroup or stratum. So what's an example of that? Let's say that I grouped people by hair color. and everyone was in their little group, and then I wrote down your hair colors and I put them in a hat, and they all had the same chance of being drawn, and I just drew out a group. Well, that would be stratified sampling, where I put you in groups, and then each group has the same chance of being drawn. In cluster sampling, we first divide the population area into sections or clusters. Then we randomly select some of those clusters and choose all the members from those selected clusters. All right. So all these are pretty straightforward. If you have any questions, you can ask or email, and I can try to straighten all that out. There's some good charts in the book. This chart here tells about types of observational studies. They're flow charts, and your book does this a lot. Gives you flow charts, like it'll ask a question, and then if it's yes or no, or on this one it's past period of time or forward in time, and it tells you, then you go to this level, and then from that you flow down to another level or another level. So it is a good idea just to kind of read through the charts when you can. All right, so depending on different times that you look at, that could tell you the type of study that was being conducted. A cross-sectional study, it says, data are observed, measured, and collected at one point in time, not over a period of time. So data are collected at one point in time, not over a period of time. A retrospective study, data are collected from a past time by going back in time. They get in the DeLorean and they just go back in time. Not really. Just looking at information from the past. What does retro mean, though? Past. So it's kind of easy to remember. A retrospective study, something from the past. A prospective study, data are collected in the future from groups that share common factors.